Okay. I think it's about live. Let me know if you can hear me. So, alright, so this is a live stream, tutorial live stream for Houdini, which is called as Houdini Algorithmic Live. This is 128th episode. And this is Junichiro Horikawa streaming. The topic for today is to create a UV based Marquee scrolling animation, procedural animation system using Houdini, like these. It's pretty simple setup, nothing really special, but might be interesting for some of you. So that's what I'm gonna do today, trying to create this kind of animation setup procedurally in Houdini, right? So let's get started. So before getting into this, let me know if you can hear it. Hopefully you could. I'll just show the brief step that I'm gonna do today. Right. So first, choose. Oops, doesn't really work. Seems like my pen doesn't really seem to work here. Well, the first thing that I'm gonna do is to choose a geometry to place the animation on. Then next thing that I'm gonna do is to create a quad mesh using some libraries for the quad remeshing, or using your own algorithm, whichever you prefer, and create a strip, rectangular strip on top of a mesh. Then next I'll create an animation for each strip, using just moving the UV for each strip. So it's pretty simple, pretty straightforward. Nothing really special, but as an effect it's pretty interesting. And I'm also going to create a textures on COPS network, like this one, with these for these text, but could be any like images, doesn't really need to be text. It could also be image of your choice, so that could also be an interesting stuff to explore. I'm just gonna show you how you could make this kind of system procedural system using Houdini, and the rest is really up to you how you could develop it from there. So let's do this from scratch as always. Right, so hopefully you could hear my voice. I'm not really sure if this is online. Hopefully it is. Well, let's just guess that it is. So I'll start from creating some random geometry. I'll just start from creating a simple geometry like cube, maybe. Later we could go back to the geometry to change with any arbitrary geometry like test geometry like pighead and so on. Okay. But first I'm gonna try with this quad. I mean cube. Right. So let's do this. So I'm going to create a switch to choose the initial geometries. Let me know if the sound is a bit low. I'm not really sure how the sound is being outputted. Okay, so let's do this. So in order to start off the animation, to create animations like I showed you, the first thing I need to do is to make this input geometries to a bunch of made by a bunch of strips, square strips or rectangular strips. So in order to do that, the first thing I need to do is to create a quad mesh out of the input geometry. Right? There are several ways to do that. One of the easiest way is to use a subdivide node, which you could create a quad on input geometry, which also changes the geometry to smoothen out. So you might need to change some of the algorithm. Like if you choose open subdivide linear, you could keep the input geometry shape and make it quad mesh out of any input geometry. If you choose this to a pig head, you could still see that the quad surface is being created out of input geometry, but the problem is it always creates more faces out of an input geometry if you apply even a single subdivide node or subdivide step. So if you don't really want to increase the number of vertices or number of faces, then you should look for the other approach. One of the approach you could do is to use the side effects labs plugin or extensions, which you could access from by installing the side effects labs extensions. You could do that for free from official Houdini launcher, I think. If you go to the launcher, go to the labs package, you could install this side effects labs for the version you have. If you have it, you could use a node called instant labs instant meshes, which uses a external algorithm to do the quad remeshing. If you are using Windows or Mac, you might need to download the application and install it in a specific directory in order to use it. But by installing this one, you could create a quad mesh out of an input geometry pretty easily. The Macintosh version is a bit cumbersome because you have to go inside the instant meshes.app, which you can download from this URL. Going inside of contents, macOS, instant meshes, have to choose like these. For Windows, you might not need to do this step. It just automatically gives you the result without choosing the extension, the executable app. So that's the difference. But overall, the output you get is pretty much the same. And for the Macintosh version, you get the original mesh as well as the quad mesh. So you want to delete the original mesh in this case. So what I'm gonna do is to create a group node to give the original mesh a specific group like original. Then after quad remeshing, I am going to delete the original mesh. Like this. Okay. And I am going to switch this to back to a cube for now. Now going back to the instant mesh node, you can choose how many like polygon faces you want to have for the input mesh. Let's say 1,000 for now for testing. Small number as possible. Okay, it's good. Alright. So now that I have a bunch of quads faces, the next thing that I want to do is to create a bunch of strip out of these quads, like gathering some of the squares like these into one strip so that I can use it as a group of geometry which can run a Marquee animation, like the scrolling animation you might see on like any website or sci-fi movies or advertisement display and so on. Okay, so I'm gonna try to pick a bunch of strips randomly for until it fills up the whole cube with those strips. So for each loop, I'm going to pick an array specifying the lengths and the direction and using them as a strip. Okay. So to do that, I'm going to use for each loop. And in order to do that, you also need to know that the previous, if you have already chosen the previous, if you have already chosen the existing quad as a strip before or not. So to do that, you would need to set up the for each node as feed back each iterations. Right. Also, for the input for the for each loop, you would want to change this to a feed each fetch feedback. Now this will make a feedback loop which can be used to get the past, the result that you get from the previous iterations for the loop, from the loop. Okay, so let's get started. For now, I am only using 10 loop, but later I'm gonna increase this to like pretty much the infinite number, so that I can loop as much as I want until it fills up with all the strip. Okay, but for now, for testing, I think it's a good idea to start off with a small number, so because you don't wanna crash the file with the too high calculation, expensive calculations. Let's start off with 10 and see what I need to do. Okay, so the first thing I would like to do for each iterations is to pick a random quad from the input geometry, any random quad. Okay, Then next thing you want to do is to define the I guess the direction, like if you want to move in this direction or to the vertical direction, or in this case in this way or in this way, and so on. So first you choose the quad, then choose the direction, then choose how many quads you want to pick for a strip. And if you already have this quad being chosen, being created previously, then if you start from this one, if you go into this direction, there is a timing that you need to stop because this strip is blocking the way for the strip. So if you more strips you have, limited number of strips, limited possibilities you could go for each strips. Okay, so you need to have all those conditions being set up inside this loop in order to create one single strip. So sounds easy, but you need to be careful what needs to be taken care of in order to create a strip. Mostly about the collisions. Okay, so that's that. So let's first create a node to choose a random quad positions to start the strip, the rectangular strip. So what I'm gonna do is to use a attribute wrangle, and since I'm gonna just create one strip at a time, one strip for each loop, I'm going to make this detail, okay, which is gonna be a most simple way to do. And let's name this starting quad face. Okay. Now I'm also going to connect the for each count node, which gives you all those metadatas for the loop, such as like iteration number and number of iterations. Okay. What I would want to have is this iteration number, which can be used as a seed value for the randomness. Okay, so let's get that first, which is an integer. I'm going to get an iteration number by accessing to the detail attribute from the second input, call iteration start from 0 up to the total number of loop -1. Okay, now I can use this iteration to create a random number using rand function, multiplying iteration by some number of your choice plus some another random numbers, which will always give you a random value for each iteration. If you also want to control the randomness by yourself with some slider values, then you could also add a seed parameter to this, which could also gives you some additional randomness to here. Okay, now next thing I'm going to do is to convert this random number, which is currently in between 0 to 1, to an index number of these faces, so that I could use that number to choose which face to become the first value, the first quad to start the strip. Okay, so in order to do that, I am going to multiply this random number by a number of faces, which in this case you could get the number of faces by n primitives. Although the problem with this solution is that it always get the whole face numbers. It's okay for the first iterations, but on the second iteration, some of the quads is already being used by the strip, and you want to extrude those quads from the number of primitives, because you don't want to choose that as a starting point for the next iterations. So in order to extrude that, one of the way is to specify which quad has already been used and which quad is not being used yet. So to determine that, I am going to create an additional group, and first off I'm going to create a group for all the primitives to set inside unused. Okay, so everything is unused at initial moment. Then after it's being created as a strip, it's gonna be converted into a used group. Okay, so that's my plan. So any quad that is inside an unused group, you can set it as an initial quad for the strip. So to do that, you could get an array of primitive numbers which is inside the unused group by using a function called expand prim group 0. The name of the group is unused. Okay, so by creating this function, by using this function, you are getting all the primitive numbers for all the quads which are inside this unused. So initially all the quads inside this unused group, so you are getting all the numbers, but later I'm going to remove the quad from unused group if it's being created as a strip. Then on the next iterations, you can ignore those strip getting by this function. Okay, so that's my plan. And now that I have this number of primitives, you can, instead using n primitives, you can use the number of the length of prims array as a total number of quads and multiply by the randomness, then convert it into a random index to get, and I'll just use floor function to convert it into a integer value. Okay, and the random primitive number will be an indexed number, the primitives at index position. Okay, and this will be the random primitive number, which could be somewhere in this geometry, which is not which is inside this unused group. Okay, all right. And after I have picked up the initial primitive, I'm going to set several information to this primitive. I'm going to specify the group, the new group. I'm going to call this start group to this primitive. Right, then I'm also going to remove this primitive from the unused group. Unused group. By setting 0, you are removing it from this group. Okay. And I'm also going to create additional group called used, which could be useful. I mean, right now the start and used as the same value, like 1, which means it's included in this group, but the start group only exists for the starting quad of the strip, but the used group is going to be used for all the quad which belongs to the strip. Okay, so that's the difference. Okay, then the addition as an additional attribute other than the group, I'm also going to apply some iteration number which can be used to determine which strip belongs to which group, right? So this could also be useful, and other than that, that might be it. So let's go with this. So let's check which quad has been chosen as a starting quad for this one. I'm going to use a color node. Let's filter it with the start, color it with red. Okay, make it primitive. So I can see that this primitive has been chosen as a starting point. Okay, I have a question from Valat. Thanks for introducing me to the hedge functions in the story encoding stream. Where did you find the group? Okay, so I defined the group here, unused, before getting into the loop. For all the primitives, I have initially set the unused group. So if you go to the geometry spreadsheet to the primitive, you see that every quad has this unused group as an initial state. Right. Then inside the loop, I'm using for each feedback loop, setting feedback each iterations and fetch feedback. For each loop, I'm checking all the quads which is inside the unused group, and check get the random quads from those list of quads and make it as a starting point to create a strip like I just wrote it here. And what's this? Rammed prim. And from there I'm going to, the next thing I'm gonna do is to create a direction, which direction to go to create a strip, and how long the strip is gonna be, and making it as one long strip group. Okay, so how does this method differs from the hedge functions setup you used previously? Actually, I am going to use a fit hedge based function in order to determine the strip, actually. So in this tutorial, just like I did before, I am going to use a hedge function. So the method is pretty similar in that case. Yeah. So if you already seen the previous, if you've seen the past tutorial using hedge functions, I think you could find it pretty similar. Right. Okay, so in order to see the result clearly, I'm going to start off by setting the iteration number to 1 for the loop. Then later I'm going to increase the loop a little bit more later. Okay, so let's do this. Now I am going to use a primitive wrangle after this. And the only things that I want to look at is the one that has a start group, which currently has the red color. And I'm going to call this strip growth. And set the group to start. Okay. So currently this function, this wrangle, primitive wrangle, only works for this red color quad. Now, the next thing that I need to do is to choose the direction, in which direction I would like to go for. It could be this direction, this direction, this direction, and this direction. And there is a chance that these quads already been used as a strip. So if the quad, if you want to go for this direction, then it's already been blocked. So you want to prevent the direction that's already been blocked by other strips. You want to go to, at least you have one empty slot to go. So in this case, this way, or this way, or this way. Right. So in order to find out, you need to search for all the 4 direction, whether those directions being used or not. Okay. And in this game, I'm just gonna search for one slot, but you could also search for a multiple number of slots if you want to avoid going into like 2 steps or 3 steps. You could also do that, but I'm just gonna check if the neighbor primitives already been used or not. Right. So let's do this. In order to do that, I am going to create for loops. So I know that I'm dealing with quads, which means you have always 4 edges. So the things you need to check is always a 4 directions, either this way, this way, this way, or this way. So first, I'm going to create a loop for 4 directions to check whether I can go or not to that direction. Okay, and I am going to start by choosing one of the edge for this primitive. I can do that by getting a half edge information by using a function called prim hedge, which gives you one of the primitive half edge number, but you don't really know which direction that is. It's pretty random. There might be a rule which edge it's gonna be taking, but from what I know, it's pretty random. So by using this prim hedge, defining the primitive number, you are going to get one of the edge number, either this one, this one, this one, or this one, as a half edge. Okay. And you can use this half edge information to get several additional information, just like the endpoint number of the edge, the primitive number which adhere to this edge, which is this primitive and this primitive, and so on. And you could also get the next half edge number, which connects to this half edge, either this one or this one. Okay. So there are tons of information you could get from this half edge information. So what I'm gonna do is to first get one of the half edge from the primitive, check the primitive which belongs to this half edge, and if this is already being used or not. If it's not being used, then I can use this for the next direction to go. If it's being used, then I can skip to a next half edge, check the next primitive, the next neighbor primitive, check if it is being used. If it's being used, then go skip to the other one and continue doing this until the last. And if all the primitives has been used, then I'll just have to stick with one primitive as a strip. If not, then you could choose one of the direction to at least have two quads as a strip. Okay, so that's my plan. And in order to check that, what you could do is to first get the inside the loop. I'm going to get the next half edge from the current half edge by using hedge next. By using this, you could get, for example, if this hedge number belongs to this half edge here, then the next, by using hedge next, you are probably, I think it is going clockwise and getting this half edge here. I'm not sure, maybe counterclockwise, not really sure, but doesn't really matter. And so by using these functions, you are getting this one in next loop. But the half edge always belongs to one primitive. In this case, if the half edge getting from the primitive number here, which is this red quads, then this half, if you're getting the primitive number out of this hedge number, then you're always getting this red number primitive. But the actual primitive information you want to get is the one that next to it, which is this one. And in order to get that, you need to use a function called hedge next equivalent. Okay. This will give you a other side of the half edge. So half edge is for each primitive you have one of the half edge for this specific edge. Let's say this is the starting point and this is end point. That's the half edge for this primitive. Now if you look from the other side primitive, this will be the starting point and this will be the end point. And that's another half edge which belongs to this primitive. Now each half edge is at the same positions, but the direction is different. Okay. So that makes you having two half edges for each edge position. Okay. and by using hedge next equivalent, you are getting the half edge informations for the neighbor primitive. If the half edge is going from this point to this point, then the next hedge next equivalent will give you the one that goes from this point to this point, which belongs to this primitive. Okay. So by using this one, you can now get a neighbor primitive information by using hedge prim, and you can now check if the primitive is inside a unused group or not. And if it is inside the unused group, okay, then let's say if this is unused, then probably I could use this as a direction to going for the strip. So I could override the hedge with the NE hedge, which in this case a next equivalent edge, which is the half edge information for this primitive. Okay. Then I could also create some flag like int has next, some flag information like this, starting by 0. Then if you could find the neighbor, the empty neighbor, which has this unused group, then I could set the flag called has next to 1. Then break the loop. Okay. Right. And since I'm looping 4 times, I need to, if this doesn't met with the conditions, then I need to go to the next half edge. So that needs to be done somewhere upside, right, and that needs to be done. I think I do need to update the half edge somewhere in order to check. Let's see. So this is the next edge. Actually, I could just say hedge is equal to hedge next, probably. Let's see. Yeah, I think that might work. Oh, nope. Making it hedge. Alright, so let's see if this works. Okay. Now currently I am only using one loop, so I'm not sure if it's gonna work. But let's say, so the things that I want to check next is whether I could choose the next quad. Okay, so let's see which direction has been chosen with this function. So I will know that by looking at the current hedge number, which is supposed to be the next equivalent edge here. So I could get those information by getting the primitive from the edge, a half edge, using the current edge, half edge, then set this primitive with some, I don't know, some random colors. Let's just color it with green. Okay, got some errors. Needed to specify the primitive number. Okay. Now I think I have some errors here. I mean, not getting any result here. So maybe I'm doing something wrong. Let's see. Let's just make sure I am resetting the viewport. Okay, I am getting the result here. So seems like this is the next group. I mean the direction that I'm going for this case. So let's go back here. I mean, well, where was it? Let's go back here and make these quads with remove those quads from unused group to test out, okay, whether this could avoid going into this direction. Because if you have these strip being set, being removed from an unused, then you need to avoid going into this direction and then have to choose other direction. So let's try that. Okay, I am going to set what can I use? Group delete. No. I'll just choose primitive wrangle for these selected primitives. Wait, didn't create it. Primitive wrangle. Huh. Okay, which one was it? Okay, I'll just pick this value here, paste it to the primitive wrangle, set prim group 0 unused prim num 0. Okay, so this will remove the selected geometry from the unused group. Let's check. I'm gonna use the color node for the primitive unused with some random colors. Okay, so this gives you the information that these quad has already been chosen as a strip, which means it's not inside the unused group. So if you have chosen this quad as a starting point, you should not go to this direction, but instead go to either this direction, this direction, or this direction. So let's check if that's what's gonna do. I think I have just I think I missed the starting point. Starting point got here instead. Okay, I guess I should move this quad one step here. Let's try this again. Okay, this one, that's it. Okay. How's this? Okay. And now, seems like the starting point also changes based on the step that I added. If I don't have this one, wait a minute. Okay, I think I am missing, again I'm missing the group to remove. Okay, it's supposed to be these positions. Okay, I think I'm a bit drunk. Okay, hopefully this time's I'm doing fine. Alright, so okay, so this is supposed to be the blocking strip, and the red one, the starting point quad must be somewhere around here. Wait, no. It's funny. If I have added the okay, that is because I am using this expand primitive group unused, so that's kind of a reason why it doesn't really give you the same result. Okay, so for now, just gonna get all the primitives for testing. So this will give you all the primitives, but I know that the initial state you are getting the primitives out of all the primitives, so you always get this primitive here, the initial state. Okay, now you are getting this red quad as a starting point, and I can see that it is avoiding going into this direction if you have this strip setting as unused group equal to 0. So instead it's going to this way, so I think it's going fine. Well, it took time to debug, but to check if I am doing correctly or not, but seems like it is doing well, so that's that. Just wanted to check if the direction is going well. Okay, now it seems good. I'm going to make this back to unused group. Alright, now next, now that I define the direction for the strip, next thing you could do is to define how many number or how many quads you want to use for each strip. Okay, so let's do this. So let's define the number of strips. It could be random, or it could be static or constant, but either way, at some point it's might going to be blocked by other strips, so you have to know that it cannot go more than the maximum number of your choice. Okay, so the best things you could do is to first define the maximum number of quads you want to use for the strip. Max strip number. And let's say it's like 10. Okay. And and what else? Maximum number of strip. Yeah. I'll just gonna use this for the loop. And if the has next is equal to 0, then there are no direction you can go for. All the direction is being blocked by the other strips. So in those cases, you don't really need to expand the strip. So you could avoid creating anything by checking has next equal to 1. If it is only if it is equal to 1, then you could go to that direction. Okay, and I'm going to make these commented out because I don't need that. And I'm going to create a loop for a max number of strip. Max strip number. And if it is equal to 1, then that means, well, you already have one single quad, which can be counted as 1, so maybe I can subtract the maximum strip number by 1 so that the total number will be equal to the maximum number. So if I tell the maximum strip number to 10, subtract by 1 it will be equal to 9, so you can add 9 quads addition to a starting quad, and in the end you get 1 plus 9 equal 10 strip, 10 quads. Okay, so I mean this is not really necessary, but just to make sure you are getting the same number as the maximum strip number and the actual quad number for each strip. Okay, now first thing I would like to do is to get the primitive number, which I already did it here, so I'm gonna copy this here. So this will give you a primitive information. Right. Now, next thing you want to do is to check if this primitive is inside the unused group or not. If it is inside unused group, then that means you can go to that you can continue going to that direction. If it is not, then you should stop going into that direction. So that's what I want to check. Okay, let me check the comments. To get a random start point, you could just run something like int rand seed numpt. Okay, numprims, I see. I don't think so, but done things procedure discord. That's because the random start point is based on the amount of prims in the unused group. What will be the workflow if the input geo those have primitives in such perfect order? Say a character information mesh. I have a question. What are use cases of eigenvectors? Use case was, as I remember, a hard surface live stream. Many questions there. What will be the workflow if the input geo does have primitive in such perfect other? In such perfect other, say a character's forming mesh. So I guess the valouts is asking what if the mesh is in perfect state and you don't really want to remesh it. Now that might be a bit hard in this case. I mean, unless you could create a UV, custom UV on a mesh without actually meshing it, might be possible in my way, but the way that I'm showing in this tutorial, you kind of need to make it quad mesh. So if you don't really want to remesh the original geometries, then you might need to think about the other way, trying to figure out how you could split, place the UVs without actually remeshing the actual mesh. That might be hard, but I think it's possible as well. What are use cases of eigenvectors? Eigenvectors could be used to define the directions and convert it into a matrix. It can be used to it's mostly for the transformations in which directions you want to scale or orient the mesh. Yeah, it's pretty important for hard surface stuff as well as trying to create like vector oriented surface and so on, like based on some flow or curvature principal, curvature directions and so on. Yeah, it's pretty useful, I think, and if you have some idea, if you get to know it. Maybe I could use that in some other live stream as an interesting use case. Yeah. Where was I? So I have now the primitive from the hedge, and I wanted to check if it is inside a unused group or not. So yeah, so let's check if in prim group unused this primitive, let's call this n prim. Okay, is equal to 1. Okay, and since I'm going to recursively add a primitive to the strip, there is a chance that in some geometries you might go around. If the strip number is really long, and go around, go back to the original direction, the original positions, and touches to yourself, there's a chance that might happen if the strip length is really long. In those cases, you also need to check if that happens or not. So let's check that by having additional informations, like creating a array called used polygons, starting off by having yourself, which in this case primitive number, and for each time you add additional primitive to the strip, you're going to add that number, primitive number, to this array. and check if the next primitive is it already inside this array or not by using a function called find used polygons and prim. And if it's negative, then that means the number is not inside the array, which means you could use that primitive for the next quad. Okay. Now, here's the part. You now could set prim group unused to 0 and instead set prim group used to 1. So remove the primitive from the unused group and instead put it inside the used group. And also set prim attrib, set the attribute for this primitive with an iteration with the value from this count, which I don't have it right now, so let's create that again. Get the iteration number from the detail and place it as an attribute to this primitive. Okay, and seem to have some errors here. What's that? Error reference to undefined variable int. Oh, I was missing I here. Okay. Now now that the things that I did here, first I get the quads as a starting point, get the half edge, and get the equivalent half edge which belongs to this primitive, and from this half edge I get this primitive number, check if this can go or not, and if you can go, then put it inside the used group, put it inside the unused group, and and that's what I did here. And the next thing you want to do is to make check the next quad in this direction. So you need to bring the half edge informations from here to here, which belongs to this primitive here. Alright, so that's what you want to do. And to do that, kind of need to update the half edge somehow. Alright, and to do that, let's see how I would do that. Now, if you have the half edge which belongs to this primitive, if you go to the next half edge, you might get this one, and the next one it'll be this one here. So if you get next half edge twice, then you get the other side of the half edge, which still belongs to this primitive. But then from here, if you get the next equivalent half edge, you get to the next primitive So I might need to do next half edge twice, then next equivalent half edge once to get to the next primitive. Okay, so let's do that. So the hedge is equal to next hedge half edge next edge, and you want to do this twice, so I'm going to create another half edge next, like that, and then you could also use a half edge next equivalent so that you can go to the other side, which belongs to the other primitive, this one. Like that. Okay. And also, one thing that I need to do is to apply or add this n primitive number to this used polygons. So append used polys with n prim. Alright. Now that should do it, I think. Let's see what happens. So for each primitive which has been removed from unused and put inside used, in order to check it, I could color the group, the primitive which has used group with green, make it primitive, maybe blue. Okay, so it seems it's working. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm having 10 quad being used as a strip. Right? And let's check if I changes the seed value for the starting point. See if it constantly changes with the same rule. Yep. So everywhere I chose, you are getting a strip with a 10 quad number. Okay, seems good. Also, let's go back here. Then if I change the number of strip, yeah, it also changes how many strip you could get. So I think it is working. Now it's time to check with more loops. Now making all the blue makes it difficult to see whether it's being produced with blocking or without blocking, without colliding or not. So let's color it by using the attribute called iteration. Maybe using random from attribute. Okay. And seems like it's a bit hard to see. Let's go from 1 to 1. So if I have one loop, I have it here. Let's increase the strip length to 10. If I have second loop, okay. Okay, starting, not not sure where it has been started off. Well, there is a problem here because the start this primitive should already be used and should be going out of the unused group, but by using this starting quad phase, it is using one of the unused group as a starting point, so that's a problem. So maybe I'm doing something wrong here. Let's make this unused and see. Anything is wrong. Let's make this constant. Okay, so yeah, this seems to be like out of a unused group. It's not being colored, so I think this is correct, but I think this one is wrong here. So I am supposed to get all the unused group primitive number here, but for some reasons I am using this quad as a next starting group. Oh, I see now. The reason is because I didn't really remove the start group in the end. So for each loop, for each end of the loop, I need to remove this start group so that it's not going to be used for the next loop. So that's what I was missing. So I'm just gonna use a group delete to remove the start group for primitive. Yeah. Now it should create some other starting point for the next loop. Okay. Well, hopefully that does the job. Now I'm going to make this random from attribute iterations and for used. Okay. Okay, let's check this again. Third iterations, fourth iterations, fifth. I want to check if it's been blocked by the. Okay, so this has been blocked. Let's check. So the starting point is here, and I can see that it's going this way, and it's being blocked by the the used strip group. Alright, so I think it's working, and if you continue this multiple times, or I don't know, 1,000 times, it should at some point just fills up all the quad with strips like this. Addition to this, you could add additional algorithm to the strip growth setup here, so that you could have more like long strips, which tries to avoid having small lengths like this one or this one. But the simplest way to create a strip is like this. Okay, so far that's fine, I guess. Now it's a bit inefficient to just run 1,000 times or 10,000 times just to fill up the space. I mean, if the number of quads is really small, then you might be able to finish filling up the space like with 200 steps. In some cases you might need to have more steps and so on. So you don't really know how much steps you need to do in order to fill up the space. So the efficient way you could do is to stop the loop as soon as it fills up all the spaces. Till then, you could make the maximum step to like really high number, like 10,000 or 100,000. So in order to check whether it's been filled up or not, you could count up the number of unused group. So to do that, you could create a null node somewhere. Could be better in the start of the loop. Let's call this check. Then going back to the for each end, I'm going to create a condition when to stop the loop. And by checking the number of unused group on a check node here. So to do that, you could use something like expand or I could wait, n prim's group check and the group that I want to check is unused. And if it is equal to 0, then that's the timing when you want to stop the loop. So equal to 0. Okay, till then you can continue looping. So let's make this loop number really high, like 1000. And I can see that it stopped at iteration 270 because that's when you have filled up all the spaces. Okay. Now if I change this to some other geometries like big head, this one has similar number of quads but should change the number of loops like 280. If I increase the number of quads, like going back to the instant meshes, make it like 5000, this will change the total number of iterations. Okay, now it says 1000, so it's not enough because it reaches to the maximum. So let's make this 10,000 as a maximum. So it says 1343. So that's when it stopped. Okay. And by increasing the strip growth, maximum strip number to really high value, like, I don't know, like 30, you could also reduce the number of loops, increase the length of the strip, like that. Now in this case, the direction is totally random because of this. Everything goes randomish. But if you want to control the directions in which directions you want to create the strips to, then you can control it by modifying this part and this part here. Problem, I don't know, based on like a vector field on a mesh or curvatures, principal curvature directions, and so on. There are many ways to control the directions, but in this game I'm just gonna make it simple to use the random directions. Alright. Okay, so far I have created the strips. Now from here I'm going to create a UV animations for each strips, making one strip as a really long, a rectangular shape. since that is a rectangular shape, it's easy to provide a UV value, and on top of this UV value you could also set a textures on it to animate it by modifying the UV U value, animating U value for each strip. So that's my plan. So before we get it into that, let me organize this a little bit. Since I have several parameters at this point, I'm going to gather all those parameters that I could control later inside one node. I'm gonna create a new node, bring all that parameters that I have to this node here. So one could be this shape parameter. Okay, one could be the number of faces for the instant mesh or quad mesh. Okay, one could be C number, random C number. Okay, and one could be this strip, the maximum strip number. I'm not sure if the term is correct. Maybe it can be called as maximum quad number for each strip. Yeah. Oh well. I'll just call this as strip number. Okay, let's make this the maximum to 100. Okay, so that's probably it for now. Alright. So let's change this back to cube shape. Make the quad number a little bit lower so that I can test it faster. Okay, and test out the random seed, maximum strip. Alright, I think it's working. Now, now it's time to create a UV for each strip. Now to do that, I guess there's many ways to do that, and you could do that anywhere. Could be done outside the loop, could be done inside a loop, and so on. But I think the easiest way is to do it inside the loop. Starting off by this starting quad face attribute wrangle. This is where you have chosen the initial quad, and you could start creating a UV information from here, from the starting point. I think that's the easiest way to like follow, because, or maybe from here, because this is where you are creating the directions, and you do need to know the directions in order to create the UV informations, right? So it's my plan. Okay, why my my pen's not working right now, so just gonna have to draw it with my mouse. Okay, so my plan is, I have a strip like this. And let's say this is the quad as a starting primitive, and if you have chosen the directions, then you know that in this directions you could use a u value here, and for this directions you could use a v value here. And for the v value you always get 0 and 1 because you only have 2 vertices in this direction. For the u value, it depends on how many points you have, vertices you have, but the maximum is always equal to 1. So starting from 0 to 1. Or it could be more than 1. If you could make a continuous UV. Making more than 1 means it's gonna be just the fraction will be used. If it's 1.5, then the 1 will be deleted and just 0.5 will be used at that point. But most of the time, I guess using 1 makes sense. So let's think like that. And I think it also makes sense to make each length for the quad, each u length same for any strip. Even if you have 2 quads as a strip or 4 quads as a strip, making this delta u, which I am going to call this as a length of the u value, same makes sense to have a similar like texture size for each strip. Right? So that's what I would like to achieve here. And let's see how I could do that. Alright, so let's see if I need, let's think if I need to do anything at the starting point. But since I am not defining the direction yet at this point, I'm just choosing the starting point. I think it doesn't really make sense to specify the UV here because I don't really know which direction I'm going to at this point. So I think it makes sense to apply a UV right here where I'm creating the growth for the quads. So let's do that. So going back to a single loop, I think it'll be easier to see with the single loop and with really small number of strip quads. Okay, so this will be a good example to start creating a UV. And this is the starting point, and this is gonna grow into this direction, and as a final result you get something like this. In this directions you want to increase the u value, and the vertical direction you want to just increase from 0 to 1. Alright, so let's think how I could do that. Alright, so I'm thinking if I should do it inside a single wrangle node, or if I should separate it into a different node. But since I already have this half edge information here, which could be useful in order to determine which points is going to be used as which value, I'm just going to use this node here to define the UV. Okay, so let's do that. Right, so let's think. So So I have two loops. This is where I was checking in which direction that I want to go for this primitive. So in this case, I have chosen this half edge here to go this direction, and in this loop I already have the half edge information for this primitive, which belongs to this edge here. So at this point, at this loop, I don't have this information, so I think I could start off by setting the UV information for this edge here, this point and this point here. So to do that, I think I need to do that here, right here, where I have defined the edge to go for. So or outside the loop, I guess. So let's see. What kind of information do I need to have? So first of all, I want to apply the half edge, I mean the UV information to vertex instead of point. Because point is gonna interfere with other, like the neighbor primitive. So I think it's better to go with the vertex, which belongs to each primitive. Okay, so in this case, the half edge here is the next equivalent half edge here. So outside the loop, I could get this edge value here by again using an edge next equivalent. Next equivalent for the half edge that I got from here, and then how should I call this? I'm just gonna call this a temporal hedge. Then use next edge twice so that I can go from this edge to this edge and this edge. So currently I have this half edge belongs to this primitive, which belongs to this edge here. By using next equivalent half edge, you're getting the half edge which belongs to this primitive, which is at the same edge here. And then using next edge 2 times, you're getting 1, 2, you're getting the other side. So that's the edge that I want to get the point number, and from that edge I can get the point number, the starting point and the end point, and set the UV value for each point. Okay, so let's do that. So next hedge. Okay, supposed to be hedge next. And do this twice, so I'm gonna create another hedge next. Like this. Okay. As a result, this half edge should belongs to this red primitive, which at this point here, the other side of the directions that I'm going. Now, from here I could get the vertex value for the starting point and end point let's call this FSBT by using hedge a source vertex for this half edge and vertex using hedge destination vertex. Okay, so now that I have a linear vertex number for the starting point and end point of this edge, I can provide an UV value for that. So let's do that. Set vertex attrib UV, and for this SVT, since I'm using linear vertex, I have to set the force parameter to 1, a -1, then set the UV value. So the UV is supposed to be, let's say, I'm gonna say 0, 1, 0. Okay, too many parentheses. So this is for the V, this is for the U. So this is, if this direction is going to be used for the U value, then the starting point must be 0 for the U. And I mean, the V could also be 0 for this one. So at this point, the V could also be 0, but if you're going, if this direction is V value, then this point should be 1. So the destination point, the end point, the end vertex, the V value has to be 1. Alright. Hopefully. Okay, now now I think what to do next. I could actually provide a UV for this vertex as well, right here. So in order to do that, I could go from I could actually just get the next equivalent half edge here actually. So let's have that. Let's have it as a parameter, I mean the variable. Okay, and let's call this one, and let's have SVT2, which is at this point here. Okay, which I could get it from this half edge here, which belongs to this primitive. Now the things that I need to careful of is that the half edge goes clockwise or counterclockwise, I forgot, but if it is going clockwise, then if this is the starting point and this is the end point for this half edge, for this edge, this is the starting point and this is the end point. So if you are going from the U direction in this case, and if you have used the starting point as set the V as 0, then you need to set the end point for this half edge to make the V value 0. So looks similar, but things that you need to change is here. I need to change this to the destination vertex for this half edge here. Okay. And this has to be source. Okay. And now I could make the SBT2 as EBT2, and I'm just gonna test by making the U value to 1 and V value to 1. Okay, and now I have just created the UV value for the single quad, the starting primitive. It looks fine. I think it looks fine. Alright. So, I think that's good. Now, I need to do the similar things just like I did here inside this loop to complete creating the UV for all the rest of the strip. Okay, and I think I need to modify the scale of the U, which currently I have just set it to 0 to 1, but I need to make it scaled so that it can be longer. It can cover all the strips with the texture, 4D texture is being applied. So let's do that. So let's think where I should set the textures. I think I need to do that before updating the half edge information. So I think I need to update the vertex UV somewhere around here. Alright. And the things that I need to do is pretty much similar to what I did here. I need to get the information for this edge and for this edge for each primitive. Okay. And for this edge, you could use like next half edge twice or edge next twice, just like I did here. So I'm going to copy all those code here, paste it here, try to modify it to make it useful. So the information I have in this loop is, first of all, I have this half edge here, which belongs to, let's say I'm looking at this primitive here. Okay, seems like it's already working, but I'm not sure. I'm not sure this is correct. So for this primitive, the edge means the half edge information for this edge here. Okay. And so actually I don't really need to do this here yet. The SBT1 and the EVT1 could be coming from the half edge itself. Okay. And SBT2, EVT2, which is for this edge, can come from the next half edge for this one. So int, let's call this n edge, n edge, and it's called edge next 0 edge, and you want to apply this twice, so edge next, like that. And now you want to apply that to here and here. And I think I need to change the name here because it's already been used here. It's better you change the variable name because it's gonna mixed up. So let's rename this to I'm just gonna add n. I mean, any name is fine. Okay. Now, probably this should do the job. Maybe not. Okay. I don't see any updates, so maybe I'm doing something wrong here. Let's see what that is. Okay, I need to kind of change these part here. So, I need to add n to every vertex number here. Alright, so hopefully this is going okay, but the problem right now is that for each primitive it's going from 0 to 1 for u value. 0 to 1, 0 to 1. But actually what I want to do is to going from the starting point, I would like to go from 0 to something like 0.1, 0.2, 0.3, 0.4, or a value of your choice. Okay, so to do that, gonna have to choose the maximum number of like quad in order to make it the UV value, the U value equal to 1. You might be able to use 5 as a maximum quad number to be equal to 1, the U value equal to 1. But in this case, I already have a parameter like this one, max strip number here. So I could say if the strip number is equal to 10, then you get until 0 to 10, 1 for the U value. But if you have only 5 quad numbers, then it might just go from 0 to 0.5 and so on. So I think I could just use this one to control the U value. So I could copy that value. Where is that value? Okay, this one. And that should go to the first row. And I am going to copy this value here, and for the first strip I am going to divide 1 by the maximum strip number. Divide 1 by the maximum strip number. For the wait a minute, sorry, that's for the V. Actually, I want to divide the U value here. Like this one, and like this one. Okay, and as a result, you can see that the U value has been skewed, so it becomes from 0 to I don't know, 0.1 or something. And what I want to do for the rest of the quad is to continuously create a continued UV value for this strip. If it is going from 0 to 0.1, then the next quad has to be 0.1 to 0.2, 0.2 to 0.3, and so on. That's what I would like to do, and that's what I need to calculate right here. Alright, so in order to do that, I could use the combination with I and the max strip number here. So let's do that. And I always need to update this U value here. So let's see, divided by e like strip number. Now need to make sure one of the value is float. Okay, float, and this could be 1i plus 1. Okay, let's see what happens. Okay, so it doesn't seem continuous right here, so I think I need to add 1 to this here, add 1 to this here, and this one has to be 2. Okay, now now I think it is continuous. Alright, good. So I think that looks good. Now if I go outside a loop, increasing the total number of loop, I'm getting all those strips with those UVs. Okay, now there's some quads that I'm missing the UVs. Now let's see why it's that. Okay. Seems like that the first quad, this has to be the first quad because it's been blocked by all the strips, and it seems like this part is not running. That is because no edge has been chosen here, which means has next is equal to 0 and hedge has not been chosen, so which means this cannot be run. So that's the problem. So actually what I could do is I could just move this outside the if condition, and that should wait a minute, it doesn't really solve it. Didn't solve it, so let's make this back. So what I need to do, what do I need to do here? Okay, maybe I need to make some conditions here. If has next is equal to 0, then just update the half edge to the next equivalent half edge. Yeah, that will do it. That. Okay, so the important thing here is that if you look at the U direction, the length is all equal for any strip, which makes it possible to create a display like the Marquee display like scrolling effect by preserving all the text size to the same size. Right, so all looks good. And now let's test out animating those UV. I'm going to use a vertex wrangle. The animating the UV is pretty simple, it's pretty easy. You just need to update the U value. That's all. Okay, so be at uv.x plus equal at frame multiplied by some speed. Let's see what happens. There you go. Now you could also make it infinite loop by going back from the last frame to the the first frame by tweaking this to something like dividing the current frame by the end frame, which will give you a value from 0 to 1, then multiply it by some integer number, which gives you how many loops you want to create for each first frame to end frame. Yeah, and that's it. Okay, and that seems to be too fast. I have only one. Yeah, something like that. Looks really fast. Okay, so next thing I like to do is to test out by placing a font or texture, a font texture. Now you could create your own textures on any like image software like Photoshop, but you could also do that in Houdini, temporarily doing it in Houdini, using something like Hop Network. I'm lazy enough to do it inside all inside of Houdini, so I'll just do that. So inside a Cop Network, I'm going to create a font node, and I'm gonna create some random textures, and also choosing your choice of font. I'll just choose Korea Bold. Trying to make all the letters in the same length so that it will fit in one texture. It's not really necessary, but just to make sure it's easy to trim out. Okay, really random letters. Okay, now next I'm going to just want to fit this inside this quad here. So I mean, it's really hard to define the size. I'm just gonna set the override size to 112, 512 to 512. Just update the size a little bit. Let's make the font size a little bit smaller, like 50. Try to fit this text inside. I mean, I guess it's not a best way to create textures, but this is just a test. Okay. Yeah, something like here. It's pretty manual. Okay. So now that I got these textures, I also add I think the black part is gonna become transparent here. So I wanna add the background. So I'm gonna create a color node, make it black, and use add to add those two textures together with some okay, I think I need to make the size of those two textures the same, so I'm gonna copy this value here, going back to the image, override size, make the size the same. Right. Okay. So this is just the temporal textures that I want to use in order to place it on top of this quads, just to test. But in reality, you could just import your own textures by yourself. Yeah. So in order to use the textures that I make using COP network, I could create some material, something like principal shader material, and then set the textures for the principal shader by looking at the COP network. Okay, so going into the principal shader, going into the texture, use texture, and I could use OP, OBJ, Geo1, COP2, Net1. I think that was the name for the COP network. And that should read the texture that I created using font. Now let's check by going back to the OBJ network, creating the material, getting the shader, and I am not seeing anything, so I think I'm doing something wrong. Yep. Okay, guess I'm doing something wrong. Let's see. So this is the textures that I want to read. Let's go back to the material again, principal shader. So hopefully I'm reading the correct. Maybe I'm missing the name of right here is different. Yeah, it says box 1, so I'm gonna rename this to Geo1. Now, alright. So currently I'm getting the texture. The problem is I'm getting all the text in rows. So I want to split it into 3 different rows and randomly pick the text for each strip. Okay, so to do that, I need to go back to where I am setting the UV. The reason why I'm getting all the texture value is because I'm setting from 0 to 1. This is the problem here. So by making it something like 0.33 for v value, I could at least get one row. Now there's some funny things happening here, but that's funny. Why is this happening here? Okay, maybe this end here. I need to also change this one here. Okay. So the multiplication of 0.333, because I have 3 rows for this textures, need to have either from 0 to 0.333 or 0.333 to 0.666 or 0.666 to 1. So I want to randomly pick those values for the v value for each strip. Okay, so let's do that by creating additional random value here. Okay, so first of all, I need to know how many how many divisions that I have, or rows that I have for the textures. In this case, I have 3. There's no way to determine from this information, but maybe I can get how many rows that I have from this information procedurally. Do I? Not sure. I mean, maybe using Python I could. I copy this parameter, but it's can't think of it right now, so I'll just create a additional parameter here to determine how many rows that I have here. Let's say I manually define that there's 3 rows here. Okay, now you could say which row are you using for this strip by using random, using iterations, multiply by some random values, multiply by adding random value. Oops. Wait a minute. Okay, my keyboard is not functioning. It might be out of battery or something. Let me check. Sometimes it happens. Okay, let's see. Okay, I am waiting for the keyboard to function again. I might just need to connect this directly to the PC. Okay, doesn't work. I might let me see what I need to do. I think I have set my keyboard to some pairing mode or something accidentally, and I am not sure how to go outside that pairing mode. Sorry, checking. Oh well. good here? Just gonna type directly on my Node PC then. Hopefully, meanwhile, if I waited enough time, it will be fixed. Okay, so where was I? And let's also add the seed value here. And this will create a random value between 0 to 1. Now I would also want to get the value in between 0 to 2 by multiplying this maximum rows number. So multiplying rows and making it an integer value here. Alright, so this will create a row number here, and next what I could do is to use this row number to choose which v value that I want to use for each strip. So I could go row divided by a maximum rows for the initial v value here, and make sure one of the value is float number. And for the next value, you could say row plus 1 and do the same for this one and this one here, and pretty much doing the same things for this one, and then this one. The one that I have 0.333, you can just replace it with row plus 1, row plus 1. There you go. So now you are choosing random rows for each strip. Yeah, hopefully. And if you play it, getting something like that. Oops. No. Okay. Wait a minute. I think I am having a little bit of problem with my controller or keyboard, really. So let me try to fix that. Okay, let me fix that. I've a little bit of problem here. I'm totally forgot how I fix this. Okay. Wait a minute. Oops. Okay, now it seems to go back fine. Sorry for that. Okay, now it's worse. It works. Okay, so one other things that I could do I could also randomize the starting point, because in the initial state you always start the UV from 0, which might not be natural if you look at this here. Maybe it's more natural to start off somewhere around this situations where text is already being scrolled. So in those cases you can go to the animate UV and add some additional randomness to the starting U value here, I think. So that's pretty easy. You can just add random random strip based numbers. So strip, I think I have a iteration number for each primitive. So since I am inside a vertex wrangle, I can get the primitive number by using vertex primitive, and you can get the iteration number, which I should have applied it as an attribute to the primitive. Then I could use that iteration number to create the random values. Yeah. Okay, now something weird's happened. If you look at here, yeah, something weird is happening here. It's not really continuously going. If I remove these iterations, okay, so no problem. So maybe the things that I got here is wrong, right? So okay, now actually this has to be vertex number, not the primitive number. That's why. There you go. Okay. You could also control the speed of the scrolling by raising these numbers, like 2, 3, and if it's a integer number, it always go round back to a starting point to loop. So unless this is integer, you could control the speed in a looping situations. That means you could create additional integer random values call this random speed by creating additional randomness based on the iterations. And set the maximum speed to something like 5 or something. Then use this instead of this constant value. You could control each strip speed randomly, making it a bit more interesting. Like that. Alright. Getting a bit interesting, right? Now, go back to the COP network, and if you don't have this color node, if you just have a font, then that will give you, oops, didn't really quite change the result. That will give you a transparent background, which is also interesting because you could see a see-through text. So it's up to you. I mean, I prefer having solid background, so I'm just gonna go like that. And not sure when's the timing to update the textures. Okay, I would prefer this. Okay, now if I change the shape to pig head, still work, because it doesn't rely on the actual geometry itself, but it just only relies on to the quad meshes. If it is quad mesh, then it just works on any shape. If you increase the quad number, still works. Might be better to increase the total loop value just in case. There you go. Okay, so let me check the comment. Is Houdini better than Blender? Well, it's up to, I mean, some would be better, some Blender is better. I mean, it's up to how you want to use it, I guess. I myself prefer Houdini because I'm used to it, but for people who used to Blender, might be better using Blender for sure. It's up to you which one you think is easier to use, more flexible to use. I think Blender is really great, but I am not that used to it, so I'm choosing Houdini for now, but I'm not sure in the future. Have you ever looked at something like field aligned parameterizations? I did a live stream using field aligned parameterizations. Yeah. Forgot what was the topic about, but yeah, that was about creating field aligned remeshing stuff or something. I think I did that on live stream few months ago, I think. Is there a way to make it sound sensitive? Sound sensitive in what way? Using sound to make the speed or controlled or the shape controlled. I mean, if you could digitize the sound, then you could use it for any usage for sure. It's up to how you want to use it, I think. The sound also has several informations like the loudness, the frequencies, the so on. It could even give you like multiple number of informations on one frame, single frame, so it's really up to how you want to use the sound for, I think. Maybe type changing. In order to, if you want to use the text to be changed based on an output, based on an external input, then that might be a challenge. Because since I'm using COP network, which is pretty legacy here for Houdini, I think it's not being updated for a while. So not sure if it works well, but I think it's possible. I mean, you could bring external input like sound informations and convert it into text here and place it like, or I mean you could use the same principles. I mean the principle that I showed you here could be used on any game engines, real-time engines like Unity or Unreal engines. You just need to export the geometry that I have here to Unity or Unreal, and then do the similar things that I did here using shaders, and then you could just create a similar effect, and probably it'll be more easier to control the textures on those real-time engines. Changing the type, changing the textures into an input-based informations, like including sound. Yeah, I guess I would prefer that. So for Houdini, you could create those setup, the one that you have UVs on a mesh, on a given mesh, then export it for Unity or Unreal engines, and later you could just do it or animate it, something like this. It's not really limited to this, but could also be, I don't know, like the river flowing, water flowing on top of the mesh, and so on. Yeah. So that's what I would think. Yeah, I mean, if I could have time, I would wanna try that. I think I don't have much time today to try bring it on to the Unity or Unreal engines, but I think it should be possible. It's not that hard to do. Right. So let me know. I think I'm pretty much done here for today. I think I've done all the things that I wanted to do for today. So let me know if you have any more questions. If not, I'll just end the live here. Meanwhile, I'm going to bring all the parameters that I have added to this controller. So I have number of rows, texture rows, what else? I could give this as a parameter, I guess, the maximum speed. I guess that's pretty much it. Ooh. Yeah, so think it just works on any setup. Let me try with the tool. Some other shape like torus. I guess the torus itself is already quad, So in those cases, I could skip this instant mesh. See what happens. Wait a minute. I think I gotta skip this part here. Yeah. This could also be interesting. I mean, one thing that I didn't do is to how I could make the direction of these strip a bit more aligned to specified direction, like based on the vector field or something like that. Well, that's one thing I could try, but only if you're interested. If not, I'll just end here. Blend-Do is just free modeling plugin for Houdini. Well, that's one comment. Okay, so I guess no questions, so let's just end here. Thank you for watching. As always, I'm going to upload the files and give you the URL to access the file to the video description page of this YouTube. So come back later if you want to try out the file to the video page so you can download it. I'm also I'm also having a Patreon page, so if you are willing to back me up, that will be great as well. I appreciate it a lot. So that's it. Thank you very much for watching, and thank you for all the comments. I'll try to do the other live next week as well with some other topic. Maybe for the next live stream I'm going to do some Vellum based, physical simulation based stuff. Yeah, it's my plan. Okay, so that's it. Thank you very much and good night. See you next week.